Welcome to Emilak Online tutorial, and before us today is this differential equation, which says that if y equals open bracket x plus the square root of 1 plus x to the power 2 close bracket all to the power of n. Now show that all this expression is 0. Now take note that this is the second derivative of x, and this is the first derivative of x. Alright, now let's start. Y, let's make the whole expression in the bracket u. So let's say u equals x plus the square root of 1 plus x to the power 2. Okay, then which also means that y will be u raised to the power n. Okay, now let's start. Let's differentiate. Here we can see that our y dy over the x here will give us n u to the power of n minus 1. Sorry, this the y du, sorry, because it's actually with reference to u. And in this case here we have that du dx now will give us take note that this in particular simply means 1 plus x raised to the power 2 or to the power of 1 over 2. Let me quickly just write it somewhere so that we can make use of it. So you can see that the u here equals x plus then 1 plus x to the power 2 all to the power of 1 over 2. Okay, so let us now differentiate with respect to x here. So here you have that du over dx. Now differentiating this, we know it is 1. Now plus, now in differentiating this, let's differentiate what's in the bracket first. You have differentiating this, you have 2x now into bracket. Now differentiating the whole of this expression here now will now give us okay, let me do it like this, then square bracket 1 over 2 then into 1 plus x raised to the power 2 all to the power of minus 1 over 2. Okay, so this will give us 1 plus now this one here we have this cancel this, these two cancel this 2 here. We have that this is x then over now this here with respect to this. Okay, let me just simplify it further. This times then this 1 over minus 1 over 2 means here 1 then over 1 plus x to the power 2 the square root. So in overall here we can say that du dx will give us 1 plus x over the square root of 1 plus x to the power 2. Okay, so we've gotten du dx, and here is the y du. So therefore the y dx will give us du dy times du, sorry, dx. Okay, so here we have that dy dx here. Our dy du here is where's our dy du? Dy du is here, so here we have that n, and our u actually is this. So here we have into x plus the square root of 1 plus x to the power 2 all to the power of n minus 1. Okay, then times now du dx, which is this, into bracket 1 plus x over the square root of 1 plus x to the power 2. Okay. Alright, to simplify further, let's take it one after the other because it might look a little bit complex, but we should need I'll actually do it step by step so that we understand how the process is. Now let us take this first, express it. Down here you have what? That y into x plus the square root of 1 plus x to the power 2 all to the power of n minus 1. Now we know that in indices, if we have for example 2x raised to the power minus 1, now this implies that 2 raised to the power x are divided by 2 raised to the power 1. Yes. Now which also implies that 2 raised to the power x over what? 2 raised to the power 1. Alright, the same principle we're going to apply here now. So here this implies that n then into x plus the square root of 1 plus x to the power 2 into bracket n, now divided by this whole expression again as we did using that indices, so over x plus the square root of 1 plus x to the power 2. Now this is for this, we just express this now. Now let us quickly express this, okay, which also here that is 1 plus then x over the square root of 1 plus x to the power 2. Now this implies our LCM here is the square root of 1 plus x to the power 2. So this in this times this will give us the square root of 1 plus x to the power 2, then plus, now this in this is 1 times this, we have what? X. Alright, so we've simplified this and we've simplified this. Okay, now let us, our dy now, dy dx here will now give us this is this, which is n now into bracket x plus the square root of 1 plus x to the power 2 all to the power of n, then over x plus the square root of 1 plus x to the power 2. Okay, times this which is this. Okay, we can now say this is x plus the square root of 1 plus x to the power 2 over the square root of 1 plus x to the power 2. Okay, now you can see that this is the same thing as this, and since it is multiplication, let us cancel out. So we are left with dy dx, which is n into x plus the square root of 1 plus x to the power 2, then close brackets over the square root of 1 plus x to the power 2. Okay, let me make this n so that, okay, alright, so in this case now we can just probably cross multiply here. You can see this over here, you have a dy dx now into the square root of 1 plus x to the power 2, then plus, okay, now you can see that from here, sorry, here you have raised to the power n. From here you can see that this is equivalent, is this actually, so y here is the same thing as this, so here we now have that n real y. Okay, so we'll probably have one stage of this problem solved. All right, so let us just put this as a, let me say, equation 1. Okay, all right, now let me quickly clean this area. All right, so what we'll do here now, let us differentiate this again. So here we have a, okay, let me do something here. That's dy over dx here. This one is same thing as saying 1 plus x power 2 all to the power of 1 over 2. Let me use a square bracket here. Then n power ny. Okay, differentiating this now. Now you can, this is using the product rule. We'll keep this one constant, differentiate this. We'll keep this one constant, differentiate this. So right away, differentiating this and keeping this one constant. So here we have, if we are to differentiate the y, the x, we now have the y, the square y over the x square. Now keeping this one constant, so we can see here this is the square root of 1 plus x power 2. Okay, now plus, now differentiating this one and keeping this one constant. So now differentiating this using this here, therefore we differentiate what's in bracket, which is what, 2x. Okay, now times, now differentiating this, the whole of this now, which is 1 over 2, then into 1 plus x power 2 all power minus 1, minus 1 over 2. Then the whole of this, we have dy, yes, dy dx. Okay, all right, so differentiating this also, we now have that y dy dx. Okay, so here this we cancel this. All right, so we are now left with that dy, the square y over the x square into the square root of 1 plus x power 2, now plus, okay, this now will give us x, then times, here we now have 1 over the square root of 1 plus x power 2. Okay, now all dy dx then equals y, n dy over dx. Okay, all right, now let's come over here, this dy here, from this here, from this, let's make dy the subject of formula here. So making dy the subject of formula here, we have that the square y over the x square, then into the square root of 1 plus x power 2, then plus, this is x over the square root of 1 plus x power 2, or dy dx, then equals, now this will now be n, then times, moving over here, if we make this one, if we make dy dx the sort of formula here, we have something like this, that dy dx equals ny over now the square root of 1 plus x raised power 2. All right, do we get that? So if I have to put this into this, we now say into ny over the square root of 1 plus x raised power 2, close bracket. Okay, all right, let me clean this. So to this effect here, now we know that the square y over the x square now into the square root of 1 plus x power 2 plus x, let me say dy dx into x over the square root of 1 plus x power 2, then equals, when you multiply here, we have n²y, then over the square root of 1 plus x power 2. All right, if we are to transpose this over to this side, we now have that dy square, d square y over the x power 2 into the square root of 1 plus x power 2, then plus dy over the x into x over the square root 1 plus x power 2, then minus n² y over the square root of 1 plus x power 2 all equals what, 0. Okay, guess we are heading somewhere. Now what is the common factor here? This is a common factor here. So what we just need to do, let me clean here again. Alright, finding the LCM here, we can say, now here we have the square root of 1 plus x to the power 2. Now take note that this is over 1. Okay, now this in this, then times this, we now have that we have the square y over the y square into, now this times this now will now give us 1 plus x to the power 2. We know that, remember in solve, that 2 times, root 2 times root 2 will give us 2. Okay, which also is the same thing. Okay, explaining further, 2 root 2 times root 2 will give us the square root of 4, which is 2. So the same application is applicable in this case. So this times this, since they are the square root and the same factor in, so there we have it. Now this times this here is 1 times this here, we now have the y x n, okay, x. Now this dividing this is 1 times the whole of this minus n square y equals to 0. So when you cross multiply, you now have that the y square over, sorry, the square y over the x to the power 2, then into 1 plus x to the power 2, then plus let me see, we have x dy over the x, then minus n square y. This times this will not give us 0. Okay, where the square y over the x square equals y this, and the y dx equals this. So let us replace this. So here you have that 1 plus x to the power 2, this plus x is this, then minus n square, n raised to the power 2 y equals to 0. Final answer. Alright, if you love what I've done, please kindly subscribe to my channel and share this video for others to learn. Thank you and remain blessed.